Okay. Yesterday we talked about simplifying. Javaris, turn around, please. We talked about simplifying square roots and how do I know, seriously. We talked about how do we know when we can factor square root and how we can't. And then we also, this is also one of the homework problems from last night. The question was, how do I factor negative 81? Now what you want to do, what you want to do is I created this nice schematic diagram that will help you decide whether and how to factor a negative square root. The first thing you want to ask yourself is, can you factor it? So yesterday, for example, we did the square root of negative 7. Well, negative 7 is a prime number. I can't factor it. So if I can't factor it, I'm going to leave it as is. So if my question was the square root of negative 7, well, we did learn that you can turn that into the square root of negative 1 times the square root of 7. The negative square root of negative 1 is I. And I say leave it as is, which means leave your square root of 7 alone. If you can factor it, if it's not a prime number, then you ask yourself, are there perfect square factors? So for example, we did a question with the square root of negative 15. Well, I do know that I can turn the square root of negative 15 into I radical 15. And then I ask myself, are there perfect square factors? Not just are there factors, because there are factors of 15. 5 times 3 is 15. They're both factors. But they're not perfect squares. Since there are no perfect square factors for 15, I'm going to leave my answer alone. So again, this would be the correct answer. Now, if we take the square root of negative 81, again, we know that's going to be the square root of negative 1 times the square root of 81. Can I factor? Yes. Are there perfect square factors? Yes. If there are perfect square factors, then you have to factor it. So again, this becomes I. And in this case, what's the square root of 81? Square root of 81 is 9. So my answer is 9i. So I like this chart to help me figure out, can I factor it? Do I need to factor it? How do I factor it? All right, so I would certainly suggest that you write this down and keep it in your notes if you need it.
What if you have like 20?
Are there perfect square factors of 20? No? 5 and 4. Right? So then you would factor it. So the square root of 20 becomes the square root of 4 times the square root of 5. Square root of 4 is 2. 2 square root of 5. Well, this is positive 20, but if it were negative 20, it would be 2i square root of 5. Okay, so yesterday we added and subtracted complex numbers. Today we're going to multiply them and then divide them. I'm going to show you two different scenarios that you are going to encounter for multiplication. The first is when you have a single term multiplied by a binomial. Now this you've seen before. If I asked you to multiply this, what property of math would you use to multiply that? You would use the distributive property, that's correct. you would do 3x times 2 is 6x, and 3x times 4x is 12x squared. But we're going to do the exact same thing, except instead of there being x's, there's an I. So the first thing I'm going to do is distribute. So I get negative 15I plus 6I squared. Okay, now, it would be nice if we were finished, but when we deal with I, we can continue. I'm going to show you, glad you asked. If we have an x, we have x squared, that's it, we have x squared. But, when we have I, what did we learn yesterday about what I squared is? What? That's what I is. I is the square root of negative 1. Good. But what is I squared?
No, I said 2. Oh, wait. 1 squared.
What? Negative 1. So we can continue to simplify this by turning I squared into negative 1. It's more confusing since you were absent yesterday. Ladies, can't we just get along? Okay, now we know that 6 times negative 1 is negative 6. Now you have to be careful, okay? If you have this, and you leave that as your answer, you're not going to get full credit. Does anybody know why?
Why?
That's what I want to know. No. Because? Because.
The numbers have to go after. I mean, the letter.
When it's attached to an I, it has to go after.
That's right. We have to put our answer. We have to put our answer in A plus BI form. That means we have to put the number part first, and then the number with the letter second. So even though this says negative 15I minus 6, when I write my answer, it's got to be negative 6 minus 15I. It's a little distinction, but we want to be precise. So I'm going to be picky when I grade your test.
So negative 15I.
These are mathematically equivalent. Just as 3x is equivalent to x3. 3 times x is the same as x times 3. But when we write it, we would not write it like this. It's improper. It is treated improperly. Good. So just as this is improper, that's improper. What? Are you just repeating these? Okay, does anybody have any questions? Is there anybody not done copying? All right. The other thing you're going to see, what's it? Yes. Is 2 binomials. On the board you see 2 different ways to multiply these. We're only going to talk about the second way. The first way, I'll copy whichever way you like better. The first way is double distribution. That's where you take each of the terms in the first parentheses and you distribute it against the second term. I prefer the FOIL method, and that's what I'm going to go over with you. Now, obviously, you're not precluded from using double distribution. I don't care which one you use. But I like FOIL. It's what I'm comfortable with. It's what I find it to be very easy. So that's the one we're going to go over. FOIL method, to remind you guys, is the first term. So I have 3 times 3, which is 9. The outer terms, 3 times negative 2i gives me negative 6i. The inner terms, 2i times 3, which gives me positive 6i. And then the last terms, 2i times negative 2i gives me negative 4i squared. The next step is to combine like terms. So I have 9 minus 6i plus 6i minus 4i squared. Well, what happens to my 2 terms in the middle? What happens to negative 6i and positive 6i when I combine them?
So, they come canceled out.
They cancel out. So these get canceled out. And that's why I have 9 minus 4i squared over here. Because the 6i and the negative 6i cancel out. Now we go back to what we just talked about because we can simplify this further.
Wait,
Yes.
you can multiply a number against I.
Yeah, just like you can multiply a number times a number with x on it. Same thing. So I know that I can take this negative 4i squared and make it negative 4. And we just learned that I squared is negative 1. So this becomes negative 4 times negative 1, which becomes positive 4. So I get 9 plus 4, giving me 13 as my answer. Yep, just 13. Update.
Where'd you get the 9 from?
Okay, does anybody have any questions?
Is that the question again?
All right. What do you, I have a question for you. You're welcome.
He said no, thank you.
What do you notice about these two binomials?
Which things?
Opposites.
They're not quite opposites, are they? The sign is the opposite. The 3 and 3 are the same. All right. Javaris. Okay, I'm bringing this to your attention because this is an actual thing. This relationship of 2 pairs of numbers that are the same with just the sign different, those are called conjugates. So the conjugate of 3 plus 2i is 3 minus 2i. So to get the conjugate of any, it's really true for any binomial, but we're only going to be focusing on Cedric. What?
The poll. He didn't finish the poll. Poll. It's poll.
Can you do it more quiet? What's quiet? These are called conjugates. It's some binomial rewritten with just the opposite sign. Now you might ask yourself, why am I telling you this? Go ahead, ask. Thank you for asking. Excellent question. But I have to wait till everybody's done copying. Answer.
Wait, can I take a guess?
The reason I am telling you this is how we're going to divide a pair of complex numbers. So here's my example. I have 2 plus 3i divided by 4 minus 2i.
Lining or not?
Right, now the first thing that you're going to do is you're going to multiply both your top and your bottom by the conjugate of the denominator. So my denominator is 4 minus 2i, so my conjugate is 4 plus 2i. So I'm going to divide it and multiply both sides by 4 plus 2i. Now, what would happen if I just did this division? What is 4 plus 2i divided by 4 plus 2i?
What?
You heard me. What is this divided by this?
Oh,
1. So what I'm really doing is I'm just multiplying by 1. That's what's nice about 1, is it can take any form that you like. Kind of like Mystique. I went there. So 4 plus 2i divided by 4 plus 2i is 1. So what's going to happen is we're changing the form without changing the value, which we're allowed to do in math. Now we have 2 pairs of binomials, and what we're going to do is we're going to multiply them together, the top by the top, bottom by the bottom. We're going to use the FOIL method. Well, you don't have to. You can use double distribution. 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. 3i times 2i is 6i squared. On the bottom, I didn't do it, but I'll do it for you here. 4 times 4 is 16. 4 times 2i is plus 8i. Negative 2i times 4 is negative 8i. And then negative 2i times negative 2i is negative 4i squared. And just like in the other problem, my middle terms cancel out, leaving me with 16 minus 4i squared. We're multiplying the whole fraction by 1, but we're multiplying the top by this and the bottom by this. Okay, what's your question? Yeah, but you can't divide the 2 by the 4 and the 3i by the negative 2i. It doesn't work that way. You have to manipulate it. You have to change it in order to be able to divide it. Because in math, you have to keep everything balanced. So if you change one part of a question, you have to change the other part as well. Always use the conjugate of the denominator. We learn what the conjugate is. Same numbers, 4 and 2i. This is a minus sign, you put a plus sign. All right, now we can simplify. So I can, now remember, now let me ask you a question. Where does this minus 6 come from? I don't see minus 6 here anywhere. Where did I get it from? I didn't just make it up and pull it out of the air. Conjugated to this. What do you mean 6i squared, Ahmed? This 6i squared. This is 6 times negative 1. Remember, I squared is negative 1. 6 times negative 1 is negative 6. Very nice. So that's where the 6 comes from.
You got the
That's the same place this positive 4 comes from. I take this, and it's negative 4 times I squared. I squared is negative 1, not negative 2. Write that. Negative 4 times negative 1, which equals positive 4. What? Well, that's I just showing you that they cancel each other out.
What cancel?
8i and negative 8i.
No, I meant in the last song.
Oh, this was a mistake.
Oh, okay. So it's going to be plus 16i?
It's 16i, yes. On the slide it says 12i. Alright, so now I can keep simplifying. So 8 minus 6 is 2. So I get 2 plus 16i. 16 plus 4 is 20. What's the matter? Okay, now I'm almost done. My answer has to be in the form of a plus bi. So what I'm going to do is I'm going to take that 20 in the denominator and I'm going to give it to each part. So I'm going to put 2 over 20 and I'm going to do 16i over 20. And that's what I get here. I get 2 over 20 plus 16i over 20. And then my last step is to simplify. So I notice that I can divide both of these by 2. I can divide 2 by 2 and 20 by 2. Gives me 1 and 10. I can divide 16 and 20 each by 4. 16 divided by 4 is 4. 20 divided by 4 is 5. Please note that if your answer is a plus bi form, it's going to be number plus number and then the I. The I is actually separate from the fraction. So you're not writing 4i over 5 or 4 over 5i. You're simply writing 4/5 and then the letter I.
That was a mistake right there.
This was another same mistake. This
No, I meant right there. Oh, that's over the minus
This?
sign. Yeah.
that's just equals.
Oh,
It just says
there's
equals.
something over it.
Yeah, the speaker, the thing that allows me to record. Okay.
So that negative 16 now, when you search the
No, it's plus 16. Okay, does anybody have any other questions? Yes, Keisha. How did I get what? How did I get this? I took this and I coiled it. 2 times 4 is 8. What? Coil. Okay, any other questions?
Can you go back to the full page?